Welcome to Workshop 4 of Quantum GIS. In this workshop, you'll be using some basic spatial analysis tools for vector data to solve a basic geography and planning problem, that of site selection. You have to find the best location for 2 new neighbourhood recycling centres in a city which already has 14 such sites. Using some data on existing usage and the population of the city, you'll be using some spatial analysis techniques to identify the best location for 2 new recycling sites. So the first thing you want to do is add in the data of where the sites are and the outline of the city. So click on the Add Vector Layer button, click on Browse and navigate to the Workshop 4 folder and select city.shp and sites.shp. Open them and choose WGS84 as the coordinate reference system. The sites should appear on the map as points, and what we want to do first of all is map them using the amount of tonnage recycled every year as a colour scheme. So right click on the sites layer and select Properties from the pull down menu. In the Style tab, select Graduated and then make sure that the column you're going to map is tonnage. Make sure then that the mode is standard deviation. This way we can see which sites have above average recycling rates and which sites have below recycling rates, and you want to reduce the number of classes to about 3 so there's not too much information on the map. Once you've done that, you can also make the points bigger by clicking on the symbol change button and changing the size from 2 to 6. This is so you can see the points better on the map. Click OK. And once you've done that, click OK. And you should see the recycling centres appearing on the map, where dark blue means above average recycling and lighter blue is below average recycling usage. We need to classify the areas of the city where the sites are being used a lot and those where they're not being used very much. To do this, we can look at the characteristics of the people who live in the surrounding area, since these would tend to be the people that use the recycling sites. There are a number of ways to achieve this, and in this practical we're going to be using a very common method, that of geodemographics and lifestyle profiles. Please refer to your handout for more information on this. So to add lifestyle and geodemographic data to the view, we click on the Add Vector Layer button, and from the Workshop folder, add cities.oas.shp. Open it up and use WGS84 as your coordinate reference system. So these are output areas in the city. Output areas are the smallest area you can get census data for, and the census data has been used to generate these geodemographic profiles. So to map them, right click on the City OAs layer, select Properties. In the Style tab, select Categorize, because we're mapping categories. We want to map profile in the column variable. For the colour, we want as many different colours as possible, so use something like spectral, and then click on Classify and click OK. So the different colours represent areas which contain the same geodemographic group. By examining the map, we can undertake visual analysis to see if there's any relationship between the geodemographic grouping and the amount of recycling that each neighbourhood site has per year. However, we can do something more sophisticated than just simple visual analysis. We can actually see if there's any statistical relationship between the two by joining the 2 data sets together. So the first type of spatial analysis we're going to do is something called point in polygon spatial join. We're going to join the data held in the site's point file to the data held in the City OA's polygon file. So to do this, we go to Vector, Data Management Tools, Join Attributes by Location. In the dialog box, make sure that the target vector layer are sites and the join vector layer is city output area. So we're going to join the table of city output area to the table in the sites based upon the shared location. We need to call it the new file a name. So browse to your Workshop 4 folder and call it something like join sites profiles. And then click Save. And then click OK. If a warning comes up about input layers have no non-matching CRS, just click OK. It doesn't matter. And it asks whether you want to add the new layer to the table of contents. Say yes. Select the WGS84 coordinate reference system. The join sites profile should be added to the table of contents as a point file. What we need to do is we need to open up the attribute table for the join sites profile layer. So right click on it and select open attribute table. This shows you that the table from the two different files, from the City OA's file and the sites file, have been joined together based upon shared location. And so in this single table, we've got information on both tonnage, in other words, the amount recycled at each site per year, and we've also got the profile of the neighbourhood in which the site's located. So we can analyse the data based upon the profile classification and the tonnage. Because some of the profile groups appear more than once in the table, such as nest builders, we can summarise the data using the group stats plugin that we used last week, so we can calculate averages. So go to plugins, from the pull down menu select group stats. The vector layer we want to summarise is the join sites profiles. The classification field is the profile of the classification, and the value field is tonnage. If you click on calculate at the bottom, it will create the summary table of the descriptive statistics. And so the profiles only appear once now, and if you look at the averages, it indicates the average tonnage that each of those neighbourhoods generates every year. And if you look, Thriving Grays is the top with 3,000 tonnes of recycling in Thriving Grey neighbourhoods, followed by settled suburban neighbourhoods, and then producers. Currently, we have analysed the data based upon which output area the recycling facility falls into. But output areas vary in size. Some are big and some are much smaller. Some recycling sites fall in the centre of the output area. Other recycling sites fall on the edge. So it might be better if we have a standard definition of neighbourhood. A simple way to create neighbourhoods is to generate buffer zones. Buffer zones are circular areas of a certain radius that surround features. In this practical, buffer zones can be regarded as catchment areas around each recycling site. Buffer zones are useful since you can use them to extract information from other layers. So we're going to create buffer zones of about 1,000 metres. So we're going to use a 1,000 metre or a 1 kilometre catchment area. The first thing we need to do is to make sure in our settings that we're going to be using metres. So for the settings pull down menu, select projection properties and just make sure that the layer units are in metres. Click OK. And then from the vector pull down menu, choose geoprocessing tools and buffers. In the buffer dialog box, make the input vector layer the sites. The buffer distance is 1,000 metres, so type that in. And we need to give the layer it's going to create a name. So click on Browse and in your workshop 4 folder, give it a name, something like sites buffer 1, and click Save, and click OK, and click Yes to adding it to the table of contents, and choose WGS84 as your coordinate reference system, and then close. You should find that a new layer called Sites Buffer 1 has been added to the table of contents, and several large circles should appear on the map of where you're over your sites. These are the 1 kilometre catchment areas or buffer zones. If you open up the attribute table of the sites buffers layer, you'll see they contain the same information in the sites attribute table. So all you've done is you've turned the point file into a polygon file and copied the data across. Now we've created our 1 kilometre catchment areas, we need to find out which geodemographic profiles fall into them. And we can do this by joining the buffer zone layer to the city OA layer using the intersect command. So from the vector drop-down menu, select Geoprocessing Tools and Intersect. In the Intersect dialog box, make the input vector layer sites buffer 1 and the intersect layer site OAs. Give it a name by browsing to your workshop 4 folder and call it something like sites buffer 1 intersect .shp. Save it, click OK. When it asks you to add it to the table of contents, click Yes. Choose WGS84 as your coordinate reference system, and then close the dialog box. And you should see that the sites buffer 1 intersect layer is added to the table of contents. Looking at the map, it's very, very busy. There's lots of information there. We might want to tidy it up a bit. So we no longer need to display the city OAs layer, so we can switch that off. We can also switch off the join sites profiles and the sites buffer 1 layer. So all we're left with are the sites buffer 1 intersect layer and the city layer. Now what we might want to do is we might want to shade the sites buffer 1 intersect layer using the geodemographic profiles. So open the properties, select categorized from the pull down menu. The column is profile, we're going to map the profiles, and again choose spectral because we want to choose a range of colours. Click on classify and click OK. And this will show you the geodemographic profiles that fall within each of the 1 kilometre catchment areas. And you can see where at the edge of the city, where the buffer zones get cut off, where there's no there was no output areas. So you get half a circle or parts of a circle. And you might want to superimpose the sites on top of the buffer zones. So just rearrange the layers in the table of contents. If you open up the sites buffer 1 intersect attribute table, you'll see you have information on the amount of tonnage recycled every year by recycling facility, and also the geodemographic profile of the people living in that catchment area. So what we need to do again is we need to summarise the tonnage by the profile by using the group stats plugin. So go to plugins, select group stats. The vector layer we want to summarise is sites buffer 1 intersect. The classification field is the profile, and the value field is obviously tonnage. Click calculate, and we get the summary table here. Looking at the average column in the table, we can identify those profiles which on average recycle the most per catchment area. And we can see that affluent achievers recycle almost 3,000 tonnes of material per year, followed by thriving greys, which cycle nearly 2,500 tonnes per year. So we can use this information to decide where we're going to locate our two new facilities. We want them to be located in areas which have got affluent achievers and thriving greys. So close the table, and we need to sort of highlight those on the map. So if we undisplay the sites before an intersect layer and display the city's OA layers, we want to select those layers which have the two profiles, affluent achievers and thriving greys, because they recycle the most. So open up the attribute table and then just do an advanced search. So you're looking for all those output areas where the profile equals, we click all, affluent achievers, or the profile equals thriving greys. Click OK. And those should appear in the table, and we should have 124 output areas which are either affluent achievers or thriving greys. And these should also be highlighted in yellow on the map. So that gives us an idea of where we can locate our new recycling centres. There's a big block in the north and there's some areas in the south. And you might want to take into other accounts like where the existing centres are so you don't overlap. So you might want to just display where your kilometre buffer zones are. So you want to locate your sites somewhere in the yellow but somewhere outside the existing 1 kilometre zones. And that's the end of the workshop.